Hello everyone. I'm going to talk about a database today, namely a metric database called DalmatinaDB. And I'm doing a lot of stuff different in DalmatinaDB. And a lot of it, Robert might hit me if he hears about it. So
I'm a peaceful guy.
Until now.
Yeah, sure.
So, first up, who am I? That's a good question. If you find out, tell me. Other than that, I'm writing a cloud orchestration software called Project-FiFo, which manages Solaris clouds. There are 2 public clouds running it by now and a handful of private clouds. I'm a big fan of solid technology like Erlang and Illumos, so that is where my stuff is built. That's where I build on, so I'm standing on the shoulders of giants. And please, by all means, do not take everything I'm going to say today too serious. I'm going to employ a time-honored tradition of humor. And I'm not taking myself seriously, so neither should you. Also, everything I say is my opinion, not the ultimate truth. While it would be very handy if my opinion would be the ultimate truth, you might be of a different opinion. Of course, you would be wrong. So, why would I build another metric database? There are like 5 million of them around. So the main problem is that I'm looking at a very different scale. I'm not monitoring an application, I'm monitoring a whole cloud. Which means the biggest cloud right now runs in 3 data centers. There are a lot of computers involved, there are a lot of machines involved. And ideally, when you run that big of a system, you want to have a general idea of what's going on in each moving part. And it's a very nice thing, a nice service to your customers as a cloud provider if you can give them an insight in their machines. SmartOS or Illumos in general makes this very nice. There's a tool called KStat, which gives you literally tens of thousands of metrics on each machine. Which you don't want to monitor all, but there are a few dozens which are really nice to have. And you can collect them, they are very cheap to get, but you need to store them and process them in some way. So I tried Cassandra, I tried Graphite, I tried InfluxDB, let's not talk about that part. And they all had their problems. None of them really fit the whole thing of what I wanted or what I needed. So what do we build? We really want to have like an operation and scale like React. React is wonderful to add a node, remove a node. The operations part of React is simply amazing. I have never used any database that's as good at this part as React. On the other hand, Graphite has some really amazing ideas because they don't do stupid shit. They do very basic stuff and they do it well. They understand what metrics are, but operating Graphite is a bit of a pain. So we want a bit of React, we want a bit of Graphite. And we also want to keep it simple. We don't want a database that does it all, because usually that blows up in your face, because it does nothing really well. It just does a little of everything. And it gets complicated and, oh my god, you have a lot of trouble. You want your data to be there kind of lively. So when you query a metric, you don't want to know what your server did 15 minutes ago. That kind of sucks. I mean, it's like, yeah, oh, you have a problem. Yes, we are the support. Can we call you back in 15 minutes because our metric database still needs to load? No, that doesn't work. You want it in a second at most, right? Perhaps if the data is 2 seconds old, you can deal with that. But that's what you want. And the last thing, and now I'm going off on a rant, you want to be open about data loss. So, there is this great blog series by Kyle called Jepson, which analyzes all of the database and how they lose data. And they are all lying about it. And I found out why, because when I started DalmatinaDB, I was very open and the webpage reads, "This will probably lose some of your data." Because it will. And everyone goes like, "Oh my god, it's losing data!" But hey, let's be honest, who thinks a metric database can lose data? Okay. Well, there are a lot of smart people in the room. Who disagrees? No one. Oh, one person. Okay, you have to tell me why eventually, but since it's only one, who's indifferent about it? Okay, you don't have to deal with operations, right? No, okay, that makes sense. So, the truth is nearly every database has some edge conditions where it loses data. And then we go a step further, and losing data is a bit like a pregnancy. You can't not lose a little data. Either you lose data or you don't. So if you claim not to lose data, you have to go through your entire stack. You can't just say, okay, my database doesn't lose data. That still means all your rest can lose data happily. If you don't run on a decent file system, you lose data. If your application does not catch any possible corner case, you lose data. If your front end doesn't retry, you lose data, right? So losing data is, it sucks, but it's part of life. So let's just be open about it and say, oh, we lose data. Hey, it's okay. And if you go into that mindset, you can do some amazing stuff which gets you really, really good throughput. So let's first talk about what's a metric. Because they're like, I guarantee in this room are about 80 people, and I'm pretty sure we have about 90 definitions of metrics in here. So for the sake of this talk, we will stick with this definition, because that's what a metric means to me, and we established I'm always right. So they are measurements, and they happen on a periodic time frame. So we have T0, and T1, and T2, and so on. And they always have the same type. Your data doesn't randomly change between a number and a string. It's not like your CPU goes perfectly, well, I'm on high load now and not on 100% anymore. No, it will stay 100% or high, whatever it was in the beginning. It is not an event. There's a very big difference between metric and event. If you're talking about events, please just forget it, we're talking about metrics today. And the next thing is it's usually viewed as averages, at least if you have a high enough resolution. But if you look at any of those dashboards you're using for your metrics, nearly every query has something like P99 or average or max or min in it. You rarely look at the raw data. So the last part is they're mostly stable. Your CPU will vary, but most of the time it has a yes.
Pedantic question. When you say periodic, do you really mean periodic, or you just mean...
Well, given I'm not a native speaker, I mean the right thing.
So there's not a constant time interval between different things?
No, there is. In metric, you measure every second, or every 10 seconds, or every minute.
You mean periodic?
Okay, then I mean periodic. Great. So I will leave this in here, and I don't have to change it, thank you. I don't mean the other thing, whatever that is. And the metric is mostly stable. So your memory usage, yes, it varies, but usually over a minute, the variance is not that big. I mean, there are spikes occasionally and changes, but through over the big scale of things, it's pretty static. So I want to, okay, has anyone here heard of DalmatinaDB? Okay, you're excluded from the next question. So we have a setup. We have 5 zones with a good I/O throughput. They have 60 gigabytes of memory, 8 CPU cores, a terabyte of disk, run on ZFS without compression. The application is built on React Core. We have NR and V values of 1. We are sending metrics every second, and we are sending more metrics than the system can handle. And we have 5 nodes with a ring size of 64. I want to have a general guess here. How many metrics do you think a system like that can deal with every second? So, do we have any bets? Oh, come on, make it interesting.
A million.
A million. What? 1,000.
0.
Yes, a lot of my code actually did that, but not the final one. So you won, but let's talk about the final project from now on, and not all the failures I had. So we have 1 million, we have 1,000. 10. 10? 10? Okay, 10. That works. It's not typed in by pigeons, right? It's going over TCP. So, anyone else want to wager?
1 billion.
1 billion?
Wow. 50K.
50,000. Okay, I actually have a few USB sticks left. I will give 2 USB sticks to the person who is closest.
So, 100,000.
100,000. See, you have to put a cent note. I put in a Coke bottle from the back. Okay, no one likes Coke. Okay, so we have 1 million, we have 1,000, we have 50,000, we have 100,000 somewhere there, and we have 100,000 was there. Sorry. You remember your bet and don't change it afterwards because I have a good memory, which is a lie. So let's see how in real core usually something like this works. So you have your TCP endpoint where it starts, a metric arrives. It goes to either spawns a new process for a write, or it takes a FSM from a from a pool. Then this worker gets all the data, it asks for the current ring in React. That goes back to the worker. That goes to the vnode proxy, that goes to the vnode, that goes to the worker, and that goes, the final reply, finally to the TCP endpoint. So we have this happening 1 million times a second, we have it happening 100,000 times a second, we have it happening 10 times a second, and we have it happening at, I think, 50,000 times a second. That's a lot. So, but we can do something about that, and now people will hate me, because we don't do the Erlang thing and use processes. We get rid of as many of them as we can. So this is where I fear violence. So we send the data to the vnode proxy separately, and I don't want to rewrite React core because it's really huge and really amazing. I just want to abuse it a bit. So we send directly from the TCP to the vnode proxy. We don't start a FSM. We don't have all the goodies of it. But we don't care. We win a per connection back pressure on that because we don't centralize it on one supervisor spawning all the processes or one pool distributing. We have it all in this one connection. We remove the bottleneck of the pool or the supervisor, which is really nice. And it gets slow if you spawn a few million processes a second, right? If that happens over again, it starts to be problematic. And we don't spawn new processes. The TCP connection is long-lived. So we have all in one process, no new processes everywhere. So the next thing is, we are going to cache the ring. So React has the ring, which is how the data is distributed and on which node is which. And instead of asking for every metric, hey, what's the ring? Oh, great. Let's use that. Hey, what's the ring? Oh, great. We just ask it once every second or once every few seconds. So that saves us a lot of time. So we have now killed 3 message sends and at least 2 processes, which is a good win. And yes, the ring changes eventually. But we open our data logs, so we don't care. Right? Yes, if the ring changes and for that second things are different, you will lose your data. I told you so. But that's cool, it works. And it's a very small time frame. It's not like this ring is cached for all eternity. It's a second. If you lose a second of data, so what? Most people measure in 10-second increments anyway. So we still have 9 times more data than them. Also, it removed the ring server as a bottleneck, because it was one. It's just, oh, give me the ring. Yeah, here you go. Give me the ring. Leave me alone. So all of this we can combine into one. And here it's called bucket dictionary because all the stuff is stored in buckets in React. And it caches the ring, and it's a dictionary, and it also groups the messages per vnode. So instead of sending, since we already cached the ring, and we are already open about losing some data if it changes, we can just go and collect a second of data per TCP connection, put it all together, and now instead of sending a message per metric that arrives, which would be 1,000,000 or 10 or 100,000 or 50 or 0, we only send as many messages as we have vnodes every second, which is a lot less, at least 1,000,000 less, or 10 or 100,000 or 50,000 less, which is a decent thing. So we went from this horrible looking complex ping pong to a very simple one. So we have a TCP connection which asks for the ring every now and then sends a big load of data to the vnodes, to the vnode proxy, to the vnode, and then gets an answer back. That's wonderful. So this is a huge improvement. So now I'm telling you, excuse me, how we can lose even more data. So we cache everything. I mean, who thinks caches are a great idea? They're not, they're horrible, but we don't care. I mean, you don't cache the results. You don't have the problem of cache validity because you cache for a write, not for a read. So everything has to go through the process anyway, so it's serialized. There is no problems with cache validity. The cache is always valid because you don't have concurrent access to the cache. You don't have the cache in the background changing because you know how it works. So we cache on the vnode level. We use immutable memory. Oh yeah, there we go. There he's angry. Mutable memory, think about it. We are just writing somewhere in memory without creating something new, without the wonderful immutable stuff. So we can overwrite stuff, that can happen. But we get away with the requirement of total order. We don't need to say that metric for T0 arrives before the metric for T1. They can swap. It works because we are mutable. We don't need to write in order if we write in the cache. Once the cache is full, we just flush the whole cache. And with full, it's just defined that it wants to write behind the end of the cache. So we flush the cache, and we're good. If the data point is before the cache, we just write it directly, because that doesn't happen that often. Usually time progresses forward, unless you use a time machine, in which case the MartinaDB might not be for you. But please come see me. So, as I said, there are some dangers with caches. Again, we go and say, yeah, we might overwrite some data. Shit happens. But that's okay, we lose a second or two. Again, who looks at every second in their metrics? No, I'm lucky. But no, you don't. You look at the aggregate, the 10-second aggregate, or the 1-minute aggregate, or the 1-hour aggregate. And that only really happens after restarts. So the time frame where that can happen is really small. But hey, I want to be open about losing data. This will lose your data. It has some memory consumption. So that is a slight problem with a cache, with a memory cache. So it grows. It doesn't grow unbounded. It grows based on the number of metrics you have, because you have one cache per metric, but it grows. And last part is, when the node crashes, your cache is lost. And that is kind of bad. But, well, we lose data, so what? See, what you can get away with when you say you lose data, it's amazing, isn't it? It's like, oh, we lose data, so what? Oh, you lost data, sucks to be you. No, but the truth is, the other systems do too. If you use Graphite, they use a cache, they just don't tell you. But if it makes you feel better, I'll happily lie. It won't lose data, use it, please. No data loss, ever. So that's a bit of a problem, but you can lose some data there, and actually you can lose, depending on your cache size, a minute or two of data. Not great, but if you have an n value of 2, it's unlikely. So let's go into some icky parts of the Erlang VM. So this is how we store metrics, 65-bit of data. I see the eye, and I go, what's this guy doing here? Why is 65? It looks much better, right? 64, it's a line with a 64 binary. It's 8-byte, it's nice. You know what's going on, right? Yes, you know what's going on, because no. You don't want to do that. You don't want to use 64 bytes. 64 bytes are evil. 64 bytes are, wait for it, a big int. That's not matching an integer anymore. If you're on a 64-bit system, in Erlang, we'll treat this as a big integer, which is really slow compared to a normal integer. Because suddenly you have to carry about integers of any size and not just one register on the CPU. So you can use up to 60 bytes, but I like the byte alignment. I'm not sure if it actually makes a difference, the byte alignment, but I feel just much better knowing it's byte aligned. So this is like optimization for the program. Could use 60. This actually is about 10 to 15% performance increase. Sounds crazy, but it's true. Next, we take the cache and the I/O and split it apart. So instead of blocking the whole vnode when you do I/O, because I/O is sucky slow, we hate I/O, we don't want to do I/O, that's why we do caching, you just put it in your own process. You don't spawn this every now and then, but you just keep it running as an I/O process and send the data, which ends up really horrible if you do it asynchronously. So I learned. Because the moment where stuff doesn't come in order at all, because, well, let's say a queuing system got filled and then the queue decided to deliver out of order and everything is horrible and I spend a weekend trying to figure out what the hell is going on. You have an unbounded queue and it takes a lot of memory when you want to do more I/O than the system can. So we just do 20 messages asynchronously, one synchronously. Check how many are there. If you go over 20, you start synchronous, you create back pressure, everything is well again. Works. Doesn't lose data. For once. That's the only part of the system that doesn't lose data, by the way. I would admit it does. And on the asynchronous calls, we don't do the call chain. We free up the vnode as much as possible because that is getting all the cache data. It's a lot. So we just send around it and use a gen server reply. Works. Next, I'm going off on a rant about storing data. Because this is how your metrics works. There's a lot of, oh yes, you can read the numbers, that's great. So the number in there represents not the value, but the time, right? So they come in and that's your metrics, and you have 9 metrics in here. And so I think, how would I store my metrics? And you go like, oh, well, it's called a time tree series. And you put it in a tree. And that looks reasonable. Who thinks that looks reasonable? Do you know that about 2 people, you're wrong? Who else is wrong? He is wrong. You're wrong too. Because, do you ever heard of time tree databases? No. So, do not store metrics in a tree. And I'm actually going to say I'm right here, like about everything else, but I'm more right here, because for a time series or a metric, you know your data is sequential. You know that 1, 2, 3, 4. You know that the access pattern is sequential. You know that the read pattern is sequential. So let's imagine we had a data structure which is good for sequential reads and writes. I mean, does something like that exist? Perhaps very fancy stuff. Someone has an idea what we could use?
Use array.
An array? Are you there? Oh no, the array is right. Because yes, it is an array. If you store it in order on the disk, it's getting stupid simple to read and write. I mean, you literally just have to read a chunk of bytes. And it turns out disks are good at reading chunks of bytes, much better than jumping around and building a tree. Who would have thought that?
File systems are tree, by the way.
Yes, but not on a block. The block is a block is a block. So,
But still, tree. Inside, on
no,
the
not
disk.
inside the block. Inside the block, it's a block. It's a sequential range of data in a block.
If you would cross the size of block, then you have tree.
Yes, then you have a tree. But do you read more than 4,000 points?
Depending from requirements.
Sometimes you do, sometimes you don't. But usually you don't. Often you don't. I mean, if you read huge amounts, it gets split over multiple vnodes anyway. But they are pretty much nice in a series, trust me. Because otherwise you have a tree in a tree. It gets worse. And file systems are smart. They try to allocate next to each other if they can, right? Unless you are running on Linux, in which case you are screwed. So I want to answer the question on the benchmark. You all are horribly wrong, which I predicted. The 5 nodes do about 9 million metrics a second. On a single node, you get about 1.5 to 2 million a second. It scales linearly. Yeah, it's linearly. Literally linearly. Yeah. So you're the closest with 1 million. A billion was a bit off, but I tried that. But that's I/O blocked in the end. That's not blocked on Erlang. That's not blocked on CPU or memory. This is I/O blocked. So Erlang can be wicked fast.
Are you writing with Erlang, with the file module?
Yes. Because it's sequential.
How many async threads?
64, I think.
Really?
But it's running ZFS. So I'm making a case for ZFS if you have noticed. If you're not running ZFS, you really need to run ZFS, because when we go back to data loss, if you're not running ZFS, no matter what database you use, you risk data loss. So now that we have the... Oh, yes, please.
Are you using SSD drive?
This was... I'm not 100% sure on the benchmark boxes because they were in the cloud and I was not allowed to go to the data center. And given they only have a terabyte of storage, my guess is yes, they are using SSD, but shared with other users. So I run in production, this system runs on spinning disks, the cloud I monitor, and that works exceptionally well.
What about like real application behind it? I mean, this is only for metrics. You are already making lots of I/O for it. What about application you have on top of this machines which you are running?
You mean, I'm trying to understand the question. Do you mean the application is running in the cloud?
Yes.
It's opaque. The metric database collects not metric, well, it collects metric on whatever you want. And what I personally am using it for is monitoring the cloud. So you get CPU usage, memory usage, I/O, network metrics.
Sure, but I'm paying for GPS and I wonder how much of this cost is going for like paying for your measurements.
Well, it's also your measurements, but because ideally,
I know that I'm paying for it for sure,
yeah,
right?
you are paying for it. Well, I don't know if you're paying for it. It depends on which cloud provider you're hosting. If you're on Amazon, you're not paying for it. Good news. And you're paying for other stuff like drone development, which is much nicer, I admit, but you're still paying for stuff. But it is like for one data center, there are 3 boxes hosting this, which also host a storage system and some other databases because they are I/O heavy boxes, so databases go there. In the whole scheme, not a lot.
Okay.
If you think about it, if you collect, if it was this 5 boxes cost. It's in the website, in the documentation, what it cost exactly. Those boxes were on test, for testing. I don't run it on the joint public cloud, so it runs SmartOS, which is really nice. Word of advice, if you ever benchmark something on a public cloud, make sure to use internal IP addresses for the traffic overload, not external IP addresses, because goddamn traffic is expensive.
But like, why do you need 9 million for 5 nodes?
Why?
Where did you get this number?
So there's a program called Hager, which is a load generator for graphite, which I adopted to send metrics in Dalmatina's protocol. And I started as many Hager nodes as I needed until the database could not handle more. So this test was driven under overload. It was not at maximum load, it was overload. So Hager was producing, I will get to you in a second. Hager was producing about 15 million metrics a second, and they got better. So the database itself keeps a log of how many metrics it writes. So it monitors itself, so to say. So it's technically 9,000,001. Okay, there was someone, there was someone. I think, you know.
We just want to say yes. You're done now. Yes.
Yes.
Right. Okay. So first, thank you. And yeah, we have time for a few questions. So
Yeah, like what's your problem? Ah, sorry.
Let's start with climate change. That's a problem.
it's just cutting heat cost. What are you worried about?
Yeah. We have wars, which is a problem of mine. Yeah.
Right at the back corner.
So, on one slide you claim that you're writing with n, r, and w equals to 1, and then you said something about n equals 2. So what about replication in there?
So the implication of n2...
No, not implication, replication.
Oh, the replication. It's configurable. If you want n15, you can run it with n15. If you want n1, you can run it with n1. The higher n you choose, the more node failures you can accept. But that's simple. So for the test, I really wanted to see what is the throughput of a node and how does it scale, so I selected n1.
And if it's configured to be more than 1, who does the fan out? Is it the TCP acceptor or TCP connection process, or something else?
So the TCP connection does the fan out, yes, but then you get to the W value, and it depends on how many it writes, and periodically it just cleans up the incoming messages and goes like, oh, we toss them away.
Yeah. So thank you. Then we're done.
So you mentioned you're using something for mutable state. What was that?
And
Process dictionary, or that really dirty undocumented trick where you can get a chunk of untyped binary memory?
No, it's called a K6 byte array, which I found on Google, which just really allocates a chunk of memory, and you have functions to modify that. So it's really dirty.
Yeah. So there's a NIF version that I think is very
It's a NIF.
and there's an inbuilt one.
Yeah, I'm using the NIF.
Yeah, like what's your problem with Cassandra?
And what's my problem with Cassandra? Let's start with the fact that on a 500 gigabyte of memory node, it managed to claim it all. Now, I'm sure after half a year of study or hiring someone who is a Cassandra expert, I would have gotten down to 200 gigabytes of memory. But it's not pleasant to use. Then I found the clustering of Cassandra is not very nice. I'm sure it works most of the time, but I tried Cassandra, by the way. I did not ignore Cassandra. I tried
In production.
In production, yes. And last but not least, the query times in Cassandra for the load I have were about 1.6 seconds for, say, a day of data. The query times of a day of data in Dalmatina DB is about 50 milliseconds or something like that, which is a slight difference. And I like to get my data fast, so that were the problems with Cassandra. Oh, and it didn't build clean on SmartOS because they don't ship the snappy binaries for SmartOS, so you had to manually compile them, which was really a pain finding out.
So your query time is a millisecond using...
Yes. Because it's sequential reads.
Back there. That one.
Me? Yeah.
Yeah.
I wanted to know if you knew PulseDB before starting the Dalmatina.
What?
PulseDB, which is
Pulse
also a
DB.
metric database in Erlang.
No, I did not know that. Sorry.
No, but
I hope it is not your project and I bluntly
That's fine.
walked over your project. But if the author of this database is here, I'm seriously sorry. But I'm really happy with mine.
Okay, we've got one more then.
What kind of aggregation do you support?
So the database itself, none whatsoever.
Okay.
And the database itself is, as the first slide stated, as simple as possible. You can write just sequential reads. There is a query engine at front end, which lets you do averages, maximums, minimums, percentiles.
But you have to fetch all the data first.
Yes, yes. Well, no, not fetch all the data first. It uses a streaming query engine. So it goes to fetches in chunks and in parallel if there are multiple series you're looking at once.
Okay, last question.
Are you open-minded also to damaged data?
Damaged data? No, not really.
That might happen if you work with mutable arrays and you're writing.
Sorry. So it might happen. No, since I don't write partial data. It's always a full metric value you write. So there is no, it's an atomic update in that sense, and there is no parallel access to it. It's sequential access to immutable data.
So you don't believe?
Well, I'm sure that given cosmic rays and memory corruption, you can have...
Okay, it's a different story.
Yeah, but that you get with non-mutable data too. But I cannot come up with a scenario where that can happen. I'm happy to be convinced there is one. Please show me and I will fix it. Okay.
Okay, that's all we have time for. Thank you, Heinz.